Hello everyone. In this video we're going to go over the first practice test for chapter 11, which is Chi-Square. Alright, so for question 1, we have some people claim that the press has a clear liberal bias, and studies have shown that many people believe that the press is dominated by liberals. However, whether the liberal journalists are actually overrepresented in the media is less clear. In order to determine if in fact the press is dominated by left-wing writers, a researcher uses a survey to assess the political leanings of a random sample of 60 journalists for the New York Times. He found that 16 were conservative, 17 were moderate, and 27 were liberal. Use a goodness of fit chi-square test to determine if the three political positions are equally represented. We're going to start by computing the expected frequencies for each seller group. So I already have the data pulled into Jamovi here. To run the chi-square, I'm clicking on the frequencies menu and then selecting chi-square goodness of fit. And then I'm moving this political affiliation variable over into the variables box. Okay. And you can see there that we have 16 conservative, 17 moderate, and 27 liberal. Okay. They're actually in alphabetical order right there. Now, we're testing to see whether the three parties are equally represented or the three political leanings are equally represented. So we're going to leave the ratios at 1, which gives us a third in each group, okay, as our expected frequencies. To see the expected frequencies or the expected counts, we click on that expected counts box. So you can see then that we expect 20 per cell. If we have 60 people total and we're expecting an even split amongst the three categories, we would expect 20 per cell there. All right, our next question is, are all the expected frequencies sufficiently large to proceed with the chi-square? And the answer here is yes, because all of our expected frequencies are at least 5. In fact, they're all 20, but 5 is the cutoff. You have to expect at least 5 per cell to do a chi-square analysis. Next, you compute the chi-square statistic, and we have it listed over here in the output there as 3.7. The p-value for the chi-square is 0.157, right, or 0.16, right, down there for question 4. Our next question is, which of the following best summarizes the results of the chi-square test and its p-value? Okay. So our p-value in this case is 0.16, which would be really weak evidence against our null hypothesis. All right, now to fill in the blanks for the chi-square test, the first number you're inputting here is the degrees of freedom for the chi-square test. It is 2 degrees of freedom. And then we're going to enter our sample size, which was 60, then this chi-square that was computed, and then finally the p-value there. All right, next, choose the best summary of the results. So in this case, we're going to look at our results and look and compare the expected results to the observed results. And we can see that, well, there are probably a little bit more liberal journalists here than would be expected if there really were an even split. However, the evidence is very weak, right, with that p-value of 0.16. So the correct answer here is B, or the second one. For question 8, in this study, we didn't give you any background information on research on the liberal bias, and so I know you can't comment on that, but you can think a little bit about the methodological rigor of this study, and in terms of what do you think is the biggest problem with this study. Right? And in this case, our sample size is reasonably large, and surveys are really the only, not the only, but a perfectly legitimate way of assessing people's political beliefs. Our concern is that if you're trying to get a representative sample, you probably don't want to just focus on journalists at the New York Times. All right, next, moving on, number 9, a student wants to know if Democrats and Republicans differ in their attitudes toward capital punishment. To investigate this question, she gives out an anonymous survey in her poli-sci class in which students indicate if they are in favor of capital punishment or oppose it. So you're going to, in this case, conduct a chi-square test of independence to determine if political party affiliation is associated with approval or disapproval of capital punishment. Okay. So we're going to do this by clicking on frequencies, and now we're doing a test of association or the test of independence here. We're using these two variables here, the political affiliation and approval, and you move one variable into the rows box and the other variable into the columns box. It doesn't matter which goes where. Either way is fine. Under statistics, ask for phi and Kramer's V. And then under cells, ask for expected counts. Okay. So our expected counts are all described over here in the contingency table. And we're not asking you in this question to report all of them, just the expected frequency for the Republican approved cell. So approve and Republican, our expected frequency in this case would be 13. Okay. Next, we want to know, are all the expected frequencies large enough to proceed? And since all of our expected frequencies here are greater than 5, the answer is yes. Next, for number 11, compute the chi-square. Our chi-square test is 10.338 or 10.34 with a p-value of 0.001. Right, so for question 12, you get your p-value right there. In terms of the summary of the p-value for this chi-square, this is really strong evidence against the null hypothesis, which tells us that there is a relationship between political affiliation and people's approval or disapproval of capital punishment. Kramer's V is a measure of effect size. We have listed down here. You'll notice the same as the phi coefficient in this case because we have 1 degree of freedom for our chi-square. Our value there is 0.43, and our criteria for small, medium, and large for this measure of effect size is about 0.1 is small, about 0.3 is medium, and about 0.5 is large. So that is a fairly large effect size that we're looking at there. Okay, so for 15, you should have chosen a large effect size. All right, next you're going to fill in the blanks. Our chi-square has 1 degree of freedom. The sample size in this case was, we have to add up all of these values. You're going to add up 9, 21, 19, and 35. So that gives us 56 for our sample size. Our chi-square was 10.34. The p is 0.001, and Kramer's V was 0.43. Next, for number 17, choosing the best summary of the results. Okay, so first of all, we know we have strong evidence against the null hypothesis, and our effect size was large. And we can see by looking at the table, right, that in terms of approval, Republicans were more likely to approve than would be expected just based on the null hypothesis. Or another way of saying that is they're less likely to disapprove than based on the null. Democrats were more likely to disapprove than would be expected based on no association, or another way of saying that is they were less likely to approve. Right? So the best summary there would be the first one. Republicans were more likely to approve of the death penalty, and Democrats were more likely to disapprove of it. And there was strong evidence against the null hypothesis, and our effect size was large. Okay, moving on to 18, we didn't give you, again, any background research, but you can consider the methodological rigor. And if we think here about the biggest problems with this study, we can look at, first of all, whether or not the college students are likely to be representative of the general population. Okay. It seems unlikely that the college students are a good representation of the general population in terms of all of their political beliefs. Right? We're not concerned about the number of Republicans, so we're fine. And also, measuring attitudes for the death penalty with a survey is fine. If you ask an anonymous survey, there's no reason to think there's going to be a problem with that. Okay, now the next questions are all asking about choosing the correct statistic. All right, so for number 19, a diner owner argues that his coffee is every bit as good as the more expensive coffee shops in town and wants to advertise his coffee as the best in town. To determine if his coffee is really the best, he conducts a blind taste test with his coffee against coffee from 2 expensive coffee shops in town. Each participant tasted all 3 coffees and reported which one they liked best. Okay, so all they're doing is selecting a coffee that they like. So if we look here at our flow chart, the first question is, are you comparing sample means? And the answer here is no, we're not. We don't have means for anything. All we know is which coffee people chose. So our answer is no. And then are the data frequency counts? The here is yes. We're just counting up the number of people who chose each coffee. And then we have just one variable, right? It's just which coffee they were tasting. So that is a chi-square analysis, right? So you could imagine this study could have been done where they computed means, but in order to do that, you would have had to say something like, have people taste each coffee and then rate them in terms of how much they like that coffee. But that's not what was done in this study. They just chose one or the other coffees. Okay, so this is a chi-square because it's frequency counts. Number 20, does preparing food yourself affect how much you like it? To answer this question, a researcher assigns people to make chocolate chip cookies or to eat the same cookies someone else made. All groups rate the cookies on an interval ratio scale where higher numbers indicate greater liking. Okay, so note that people were randomly assigned to two groups, right? And these two groups are then rating the cookie. So we have two means we're comparing. We're going to compare the people who made the cookie themselves to the ratings of the cookie from the ones that they were just given, that they did not have to make. So we are comparing sample means, yes, and we're comparing two of them. And then the question is, are there independent sample means? And they are. They're different people in those two groups, right? So that would give us an independent measures t-test for number 20. For 21, a nursing student is considering working in a neonatal unit in ER and in surgery. He wants to know which position has the highest stress levels, and so he asked 25 nurses in each of the 3 units to complete a stress survey. Scores on the scale are interval ratio, where higher numbers indicate greater levels of stress. Okay, so the question is, are we comparing sample means? The answer is yes. We're comparing 3 of them, right? We're comparing the stress levels in neonatal, ER, and surgery. So we are comparing sample means, and we're comparing 3 or more. So now the question is, well, how many grouping variables or how many independent variables do you have? And we just have one, where they work, right? So we have neonatal, ER, or surgery. So we have one variable with 3 levels, and that would give us a one-way ANOVA. For number 22, a cognitive psychologist studied the effects of math anxiety on the speed of solving arithmetic problems. Students were tested on the mathematics anxiety rating scale and separated into high, medium, and low mathematics anxiety groups. Half of each group then solved easy 1-digit addition problems, and the other half solved hard 2-digit problems. The independent variable was how long it took the participants to solve the problems. Okay, so here the question is, are we comparing sample means? Yes, we're looking at, on average, how long it took them to solve the problem. And we're comparing the means, actually, for 4 groups, right? Or actually 6 groups. We have high, medium, and low. And then within those groups, we divided them in half. So there's 2 separate independent variables here, high, medium, and low anxiety, and also hard versus easy addition problems. So it would be a 2-by-3 design, and that would be a 2-way independent measures ANOVA. For question 23, a researcher wants to know if reading speed is associated with grades. To investigate this question, she gives 30 students in one of her classes a test of reading speed that assesses the number of words read per minute. She also records each student's grades on the final exam as A, B, C, D, or F. So what we're looking at here is the association between 2 variables. We're not comparing means, right? We're not looking at the average grade in the class, nor the average grade per minute. We want to know if these 2 variables are related to each other. So there are no means. And the data are also not frequency counts. We're not just counting up the number of people who got, say, A's or B's in the class. So they're not frequency accounts, right? But what we're looking at is, are the variables measured on an interval ratio scale. And in this case, we have reading speed, which is graded on an interval ratio scale. But final exam scores, A, B, C, D, or F, would be actually ordinal data. Right? So no, we don't have any information about the plot. But since one of the variables is ordinal, it's a Spearman correlation. In this activity, we just asked you to find whether or not it was a correlation rather than distinguish between Spearman and Pearson. But this one would be a Spearman. Next, for question 24, is a class project. A group of students performed an observation study. The students waited at a busy intersection and recorded the gender of each driver they saw and whether or not that driver was currently using a cell phone while they were driving. Some of the students thought that males were more likely to use cell phones than females, while others in the group thought that the opposite was true. What statistic would you use to determine if there's an association between gender and cell phone use while driving? Okay. So in this case, the first question is, are we comparing sample means? And the answer is no, we're not collecting data that would allow us to compute means. All we're doing is counting up the number of males and females who are either using or not using their cell phone while driving. So they're not sample means, what they are is frequency counts. Okay, so they're frequency counts, and we have two separate variables that we're looking at, gender and cell phone use. Right? So this would be a Chi-Square test of independence. And we didn't ask you to determine if it's independence or goodness of fit, just that it's frequency accounts, and because of that, it's a Chi-Square test. 25. 10 politically active individuals are selected, all of whom label themselves as liberal. Each is attached to a physiograph, and heart rate is recorded while a sequence of 20 slides is projected on a screen at which the participant is looking. Half of the slides are pictures of famous individuals without any expressed political philosophy. The other half are known conservatives. The arrangements of slides is random. Each participant receives 2 scores. The first is the average heart rate during exposure to the neutral slides, and the second is the average heart rate during exposure to the conservative slides. Okay. So in this case, we have 2 separate means we're comparing, the neutral and the conservative slides. Everybody in this case did both, right? They saw the neutral slides and the conservative slides. So are we comparing sample means? Yes. We're comparing 2, neutral and the conservative. And then we are looking at, are the samples independent of each other? And the answer is no, because the same people were measured twice. It's a related samples t-test. Finally, for 26, a teacher wants to determine if students can perform better than chance on a very difficult 40-item multiple choice test. Each item has 4 choice alternatives, so by chance a student would get 10 right. And the test was given to a random sample of 20 students who achieved a mean score of 15 with a standard deviation of 10. All right, so are we comparing sample means? Yes, we're going to we have a mean of 15, and we're comparing that sample mean to a value, right? We're comparing it to chance performance, which is 10. So we only have one sample mean, and we do not know the population standard deviation. So because of that, it would be a single sample t. All right, so that is everything for the Chapter 11 Chi-Square practice test. And good luck.